All right, good afternoon, everybody. I hope we are doing well. Um, I know some of you did take the October test and you got the results, right? So, did you guys take the October test?
I did.
You didn't.
I didn't.
You took the test though.
No.
No, you took the test. You got the results.
Mm-hmm.
So, are your scores what you expected, less than that, or more than that?
Science went up by a lot,
How much?
like 6 points or something like that.
Wow.
From last time.
And you thought science was you didn't have hardest.
Yeah, I don't know. I was shocked by that one, definitely.
So okay. How about the overall?
I went 1 point down.
Overall,
Yeah.
after going 6 points increase in
Mhm.
science.
Yeah.
So did math hurt a lot?
I went down by a little bit more than I expected.
Hmm. How about anybody online who took the test and got the results? Can you speak up?
What's your final score?
But
What was your
I'm
final?
not saying.
Oh.
Sorry, yeah.
How about anybody online? Did anybody take the test online? Take the test and got the results? I know many of you took it. Maybe they are in mute. I'm on mute. Yep. Sorry guys, I was on mute to online students. So can you hear me now? Okay. Okay. So the question I was asking them is, did anybody take the test, October ACT test and got the results? Okay, so I see one. So Kirsten, can you speak up how it went? Unmute and talk about it.
Yeah, what do you mean? Like how the test went, or?
Yeah. What did you? Was your scores? Was this your first time?
Yeah, it was my first time. It was a little harder than I expected, but I also scored better than I expected, so.
Okay. All right. So from this group, the highest is 35. So okay. So we'll see what happens in December. Okay. One of the biggest thing I'm going to recommend you guys is if you don't take the full practice test, you will be unprepared. Okay. Full practice test is required. Now, how many are coming on December 7th ACT review? How many have registered for that one? 1, 2.
I don't believe I registered. I think my mom may have.
Yeah, I think so. You're registered. Question 4. Is anybody else interested? I know it's past due date, but I can see if I can sneak you guys in. Is anybody else interested? Okay. If you're watching online this recording and if you decide to, I can't do anything after November 20th. I know that it's impossible. So if you decide to change it, if you decide to join this session on December 7th, just let me know immediately and I'll see what I can do. No promises, by the way. Okay. So what do you think you need to do here, by the way, for your to improve your scores?
Practice more.
Practice more.
Yeah.
How about you, Kirsten? What do you think you should do more?
I think I need to just practice more of the basic problems so that I can do them faster and be able to spend more time on the difficult stuff.
Yep. Practice, right? So do you think now, after getting the scores, do you think you guys now can, I had asked this question before the you got the scores. Now I'm asking after you got the scores, how much the classes helped. Let's call it on a 1 to 10 scale. Okay, 10 means it has helped the most, like 100%. 1 is it has not helped at all. So what do you think now?
Say 7.
7.
Yeah.
How about you, Kristen?
8.
Okay. What do you think we should do better or more? And remember, December might turn out to be completely a different test, okay? So we know that.
I don't really know. You'd have to come back to me on that one. I have to think about it a little bit more.
Okay, think about it. Text me, call me. How about you, Kirsten? What do you think we can do more or better?
I can't really think of anything specific.
Looks like we're doing pretty good then. Okay, all right. Let's get rolling. Get your math packets. We are gonna start with page number 5. Trigonometric wave functions. We have covered quite a bit, by the way. We are left with only 5% of the curriculum. Okay. Page number 5. Get your calculators. Make sure it's in degrees mode. All right. The next topic we're going to study in the trigonometric wave functions, I've seen once in a couple of testing or once in 3 tests you'll see this. However, as we are targeting a 36 score, you need to know all of these. So, I don't want you to write anything. Okay? What? Just listen up. Okay? And online students, make sure to stop me if you're having any questions. This is important, okay? So, the first thing we're gonna do is, we're gonna plot a simple trigonometric function y is equal to sine x. So that means if you have an xy graph, okay? If y being the y-axis, okay? This is your x-axis. So what happens when I plot y is equal to sine x in your calculator? Okay? Get your calculators. And you need to follow me slowly and carefully so everybody is on the same page. Go to window. On the window, I want x minimum as negative 180, x max 180, y minimum negative 5, y max 5, and for x scale, make it as 45. See if you guys can get this, okay? Do you have x scale? Okay. You are all on the same page? Remember, I really need your involvement because it's all graphing today, okay? So, and if I'm going fast, you need to tell me when to slow down, okay? I don't want to go fast. Then, on top left of the calculator, it says y is the y is equal to equation. Click on that one, and type y1 is equal to sine x like this. And I want to make sure that everybody's on the same page. You guys good? Online students, you have to stop me if I'm going fast. Because once you lose it, the whole thing. You guys good? Okay. All right. On the right side of the calculator, there's a button called graph. Click on the graph, please. Do you guys get something like this? Online students, do a thumbs up, please. You guys have to get involved, otherwise I'm just going to waste time then. Okay, good. We're all on the same page. Okay? So, when I plot a simple y is equal to sine x, I get a graph like this. sine 0 is 0, it starts from 0, 0 coordinate. Okay? This is negative 180. This is positive 180. Guys, good? Now, the number in front is called amplitude. And that number right now is 1. It's understood. This is 1. This is amplitude A. Sounds good? If you've heard the word amplifier at your home, like a home theater, if you have a home theater and you have an amplifier, that's what it does. It will amplify the signal. Sounds good? That's all it does. It takes a signal and amplifies it. Now, go to y2 and make it 2 sine x and graph it. Don't erase the y1. You guys got it? So what happened? Now this is 1, this is plus 2. So the graph has remained the same points. So these points have remained same, am I right? These are called nodal points. These are called nodal points. So nodal points don't change when you change the amplitude. Okay? Only the y value changes. Guys got it? So far, you're only playing with amplitude. Good? Good. Now, change the x minimum and x max to negative 360 and 360. Change that, please, and graph it. Guys, got it? Got it? Okay. Now, so when you graph negative 360 to positive 360, let me focus on the positive side here. It goes like this and comes here, right? This is the definition of a one wave. This is one wave. Okay? Also called a period. So one wave will have one peak, one trough, and will have 3 nodal points, 2 equal amplitudes. Sounds good? So this is 360 degrees, which is also in pi radians, it's also called as 2 pi. Sounds good? So, listen up. A wave is a very important thing in physics when you study wave physics. Also called a period, a one complete wave. So period is defined as 2 pi or b. Now, where the b is coming from is a question. Now, when I write y is equal to sine x, I'm going to write it as now y is equal to a sine x, with a being the amplitude. Now, if I write y is equal to, let me call y2, a sine bx, which is a coefficient of x inside the parentheses, okay? That is the b I'm talking about here. When b is 1, period is 2 pi, which is 360. Sounds good? So, for sine and cosine, the period is 2 pi over b. Whether it's a sine wave or a cosine wave, the period is the same. Now, go to y3 here. Go to y3 and make it as sine 2x with the 2 inside the parentheses like this. And see what happens now. So your period now is 2 pi over 2, which is now pi. So that means it only took 180 degrees to make a wave. You guys with me? So this is 360. So it took me 360 to make a wave. This is 180, right? So it's going to take, if the amplitude is 1 here, the amplitude still is 1. And this is the half of the wave. So it's going to be now like this. Well, I should draw it carefully. Make sense? So the waves completed in 180 degrees. That's your period. Amplitude did not change. 3 nodal points, 1, 2, 3. Making sense? Good. Next. If I have something outside of this parenthesis, this is called a vertical shift. That means I'm taking the wave up and down. What I would like you to do is now, I want you to erase y2 and y3, please. Erase y2 and y3. And I want the new y2 to have sine x in the parentheses plus 1 outside the parentheses like this, which is called the vertical shift. I'm taking the wave and moving it up by 1. Everything moves up in the vertical direction. Make sense? Can you see that? So what happened here so this is y is equal to sine x, okay? In the y is equal to sine x plus 1, if this is the 1, this point goes here, this point goes here, each point goes by 1. So if this is the 1 here, so imagine this point goes here, this point goes here, this point goes here. So now we have this. So this point goes here and back here. Look at that. Nothing, the shape did not change, right? Nothing changed. It's just that the wave has moved one. Again, 3 points. Period did not change. Amplitude did not change. Nothing changed. So what's a vertical shift? You take the wave and move up and down in the y-axis. I want you guys to write down this. Go ahead. Because once you know this, cosine is the same exact thing. So I'm not going to teach you cosine at that time. It's the same thing.
Do we have to write like the numbers?
I would write this down just as your reference, okay, for window. It'll be good to have that as a reference.
So would we have that every single time? Like, do we have to put that in every single
Yeah,
time? we have to
based
take-
on that equation, you'll have to play with these numbers to make it look like it fits in this. That's why I wanted to make sure you guys know how to play around with this. That's the biggest mistake people do when they teach trig. They don't teach you how to play with the window. If you don't know how to play with the window, you are not able to get a good wave in the screen on the screen. Does anyone have any questions so far? We need to study college physics. This is going to be all wave physics is all here. So this is the starting point. So you need to be very good at this. Stop writing, listen up now. So we have y is equal to a sine x, sine bx, and we're gonna add one more term, plus c, plus d. A is amplitude, d is the vertical shift, b decides the period, okay? Now, so what does C stands for? What I would like you guys to do is go to y1 and do sine x, please. Okay? And do y2 sine x minus 45. Guys got it? Please graph. You guys got this? You guys got it? Okay. So now what happened is the question. Yeah. So you had a wave, but it looks like it got moved, right? Did it move to the right or to the left? Did your second y2, was it to the right of the first one or to the left of the first one? Right, right? If you have a colored graph, you actually can see the red is in the right side of it. So now, depends on who the teacher is or depends what the book is. Sometimes people write plus C, sometimes they write minus C. Doesn't matter to you, okay? Whether it's a plus C or minus C. What matters is, if it's x is minus 45 degrees, the first thing this indicates is the graph shifts to the right. That's very important, okay? Second, that's called phase shift. And phase shift is C divided by B, okay? And I always write like this, absolute. So C is negative 45, divided by B is 1 here, this is my B, divided by 1, 45 degrees. What is important to you is, and if it is negative, it moves 45 degrees to the right. So you took a graph, you moved horizontally to the right. This is the phase shift, more like a horizontal shift. This is your vertical shift, which is on the y-axis. This is on the x-axis. Make sense? Now, take y3, do sine x plus 45. And now you can carefully observe what happens to your y3 graph. It's going to be on the left-hand side. You guys with me? So if you plot the graph, so this is the original graph, then you have a movement of 45 degrees. Let's say this is 180, 90, so let's call this as 45 here as a reference. 45, 90, okay. So your graph now has gone like this. Now this one, if I plot here, it's going to start from here. You guys got it? So now the directionality, so plus 45 means it has started, it has moved towards left side, minus 45 it has moved to the right side. You guys got it? Go ahead and write this down. Now remember, I'm not spending time on cosines, exactly the same thing. Yes?
So is C always gonna be like 45 or like?
It can be any degrees, basically. But this represents degrees. So now, I want to talk about the radian concept of it as well. I want to get to that one, okay? And that's why your calculator is in degrees mode, so we're going to follow only the degrees mode. And I want to talk about this. You guys good? Okay, now, go to your calculator. So your y1 is sine x. Your y2 is sine 2x minus 45. Okay. Graph it, please. Now, this one we did sine x minus 45, right? It moved towards right by 45 degrees. Now, how do you calculate the phase shift? It's C divided by B. What's my C? So phase shift is C is 45 degrees divided by 2 is 22.5 degrees to the right. If you want to get a comparison of what it looks like, you can try y3 with this. try Y3 with this, and you'll actually get a pretty good idea how the shift has happened. Sounds good? You can try this with Y3 sine x minus 45 to get an idea. Got it? You okay? Online students, did you guys get it? Okay. Looks like they're okay with this. Now, what he was asking is about radians thing. So this was in the ACT, so listen up please, okay? So of course you guys have the graphing calculators now, you can get an answer very quick. So this was an ACT, and the answer, there were 5 answer choices, 5 graphing options. The question was like this: y is equal to half sine 2x minus pi by 2 minus 1. This is what they gave, okay? Of course it looks all complicated, but it's not. The one thing I really want to focus today, and I want your fullest attention, is when you have pi, which is a radian, right? You have to convert into degrees in your calculator. Sounds good? Because your calculator is in degrees mode. What is pi radians? We did this. How many degrees is pi radians? 180. So 180 divided by 2 is 90. So in the calculator, instead of pi by 2, you put it as 90. So I'm going to show you, this will shift to the calculator. I'm going to write y calculator so you can see minus half, half. But when you're typing half, you're going to type like this, in the parentheses like this. Then sine 2x minus 90 minus 1. This is how you're going to type this. Sounds good? I want every one of you to clear out your y1, y2, y3 and graph this, please. You guys got this? And if I have to do the problem, if they had asked any of it, you can do amplitude is half, amplitude is distance, so distance is always positive. Vertical shift is -1 or 1 down. Period is 2 pi or 2, 2 pi or 2, which is pi, which is 180 degrees. I always do it in degrees just to be on the same, because calculators, and phase shift is C divided by B, 90 divided by 2 is 45 to the right. To the right because of this. I don't think so you're gonna get anything more than this in ACT. And I hope you graphed it. When you're typing this, you have to be careful. Complete this, I'm gonna write down. Now please remember this cosine is exactly the same. There's absolutely no difference. Everything is same about cosine.
I have a quick question. If you did see like this problem on the ACT, what would it be asking us to solve, and what were like the question option choices be?
Okay, so when this question was asked, they had 5 graphing options, and they asked which one is represents the correct graph basically. Of course, now you have the graphing calculator, you can actually plot it. What the other problem I've seen kind of similar to this is period and phase shift. They've asked what's a phase shift and what's a period. Those are the 3 types of question I can expect from this. Amplitude, of course, is easy if you want to get asked. Does that make sense?
Yeah, that makes more sense.
Okay. Well, if it's a graphing problem, you just graph it with using your calculator. So, but I cannot emphasize enough to convert the radians to degrees. And people who are listening to this lecture video, I would caution this. Don't make the mistake of going with the radians. Not that it's wrong or anything like that. It's just it's safe that way. Now, moving on to tangent. I'm not going to spend too much time on tangent, okay? Go ahead and get your calculators. Go to the window. Make x minimum negative negative 180 and x max 180. And keep everything else the same, okay? Now, go to y1. Type in tan x. And graph it, please. You guys get this? Like a waves and waves and waves? Okay. Now, get out of the graphing mode, please. Go to the normal mode. Do tan 0, please. Tan 0. 0, right? Tan 0, 0. Do tan 45 degrees, please. What do you get? 1. So let's call this as 1. So tan 45 is 1. Do tan 90 degrees. What do you guys get? Error. Okay? So that's what I want to talk about. So tan 90 degrees in calculator shows as error, but in the mathematical word, we call it as a vertical asymptote. Okay? So that means there is a value of tan 89, there's a value of tan 89.9999, there's a value, but the minute it reaches 90, it's infinity. That's why we call it the vertical asymptote. So you can see the graph goes like this, but it never touches this. And so forth. So if I go negative 90 here, and it's going to go like this. Of course, I could have drawn that better, but anyway, you get the point. You guys with me? So, when you talk with tangent and cotangent, you deal with what's called the vertical asymptotes. Okay? The only thing you need to do is, you have to know on this is period is, in sine and cosine it's 2 pi divided by b. Here it's pi divided by b. B is again the same thing here. You with me on this? So in this case pi is 1, b is 1. So pi divided by 1 is 180 degrees, which is basically 90 here, 90 here, 180 degrees. That's what we call a wave in tangent. The rest, everything remains same. Make sense? So that's why we draw it with a dot and a vertical line. Now go to X minimum window, please. Make it as negative 360.
I have a question.
Yes.
So if B was like 2, would the vertical asymptote be at 45?
So if it is 2 here, it'll be pi divided by 2, it's 45. I'm gonna get to that one actually. So I wanna do, oh shoot, I forgot. Change the window from negative 360 to positive 360 and graph it please. Just the tan X. See what happens. You see the graph, so you can see the waves, right? And if you take those waves and if you try to draw, like if I have one more line here, right, like this, so you can imagine this dotted line in between, right? That's your vertical line, which is a vertical asymptote. Now, what I would like you to do is go to Y2, and do tan 2x, tan 2x, and see what happens to your period. So it has become now 180 degrees divided by 2 is 90 degrees. So you'll have more lines coming out. Because now you're trying to fit one wave in 90 degrees. That's from 45 to this 45. Does that make sense?
Yeah.
You guys good? Now remember, sine and cosine are exactly the same. This is what you have to know, tangent. And whenever you have an error in your calculator, that's where you have an asymptote. You guys good? Go ahead and write down this, please. All right, so I want to talk a little bit about the remaining part of the class. So today is November 10th. Next is November 17th. November 24th is a holiday because Thanksgiving week, and December 1st is our last class. Now, I'm left with literally one topic in math, that's statistics. So, I think, and by the way, we usually don't cover this. This is the first time I've covered this in maybe 5 semesters. Usually don't get time to finish this. So I'm going to be finishing off math. I'm going to do some practice science passages next week. I'm not going to do the entire test because I want to divide that into, and I want to do a little bit more math. So I'm going to do half science, half math, 2 times in a row, so that I have covered everything, and we're good. So December 1st is our last day of the class, and I just feel we're in a really good position. December, I believe 7th is our ACT review, and December 14th is your real ACT test. So today is November 10th,
What day is the 7th?
Saturday.
Saturday?
Yeah.
Okay. And that'll just be our normal times?
The ACT test review,
Yeah.
that is 12:30 to 4.
12:30.
It's a long time here. So one of the things we have done this is the first time actually we have planned this way, that usually our last day of the class was actually the day after the review, which is December 8th, but we changed this time only because we had a 3.5-4 hour test, and next day people did not show up because they were tired, understandably. So we moved this completely this time by 1 week. So English is done. Was Rikav here last week, right? So yeah, so Rikav is good. Next week we'll be reading. Lily will be done. Today is Aubrey's last class, so we are kind of very well placed. So today Aubrey is going to be doing some real math practice tests with you guys. Okay. As I said, we feel we are in a very good position. We'll finish off by December 1st. We're good to go. Take a quick 5 minutes break. She's going to come here, continue with more math. I'll see you guys next week. Bye-bye.